Let's see some more characteristics. They are very hard and compact. So you can see this. Okay, you can crush. So you can put particular stone. Throw this stone against. You can throw this stone on roads as well. Don't do this. And it is very hard. It is very dense. It will be very heavy. Okay, because density is great. And as the density is greater, is what? Durable. Durable. And it will have what? Homogeneous structure. It will have a uniform mineral composition. You can see here. This is what one of the basaltic rocks, basaltic stone. And here there is no layer. Here the density is almost same. Here there is a uniform mineral distribution. And they are usually non-porous. Means water would not going to pass through these rocks because they are closely packed, because they are very dense. So the distance, or let's say the gap between the atoms and molecule is not there. If it is not there, so water will not able to. Okay, density is greater, closely packed, atoms and molecules are there. That's why this rock is yes, we have a pumice and scoria are the rocks, and yes, they are to some extent porous, but if you see other rocks, they are not porous. Primitive, I told you, parents rock means all the rocks which are there, sedimentary or metamorphic, they are actually the result of these igneous. Okay, so igneous rocks are basically the parent rock. Here let's see some of the example of igneous rocks. So here we have a basalt, then we have a pumice, then we have a obsidian. Obsidian is a kind of rock that during the ancient time period, when our forefathers, those who used to hunt animals, they used to hunt animals with the help of obsidian. That much sharpness was there with the obsidian. It's because the obsidian is basically a denser, a sharper, and resemble the perfect crystalline structure. It was used to hunt. Then we have a rhyolite, then we have a scoria, we have a diorite, then we have a granite, we have a gabbro, then we have a diabase, then we have a diorite, we have a pegmatite, and we have a peridotite. So these are the types of igneous rocks. Just remember some 4 or 5 examples. Question is there inside. So these are the features of this. Moving ahead. So when you see this igneous rock, or let's say when the magma is actually coming out from the interior of our earth towards the surface, so as you know that this crustal part are basically comprised of lighter silica, and as compared to the depth, you go deeper, so we will have what? Denser material in general. Silica is there, let's say. So when the lava and silica used to mix with each other, specifically in this case, so when this lava is there, when this lava is getting cooler, when it is getting cooler, it will getting cooler with the surface of silica, or let's say surface which is comprised of silica. So when it is mixed with the silica, based on silica content, we have a 2 set of rock. Again, when this magma is rising, or when let's say this lava appearing on the surface about to get cool, while cooling, it will settle on the silica surface, say silica slope you can say, and when it will going to settle, silica would going to mix with the lava, and when the silica would going to mix with the lava, based on silica content, we could have a 2 set of rock, acidic rocks and basic rock. We could have a acidic rocks and basic rock. Acidic rocks are those rocks in which the silica content is very high, and the silica content is beyond 65%, silica content is beyond 65%, that rock would be called as what? Suppose the lava is actually getting cooler, and while cooling, the more part of silica, if it is there beyond 65%, same would be known as acidic. As silica is here, because of silica, it will cool fast. It is viscous. It will be like thicky. Okay, and as it is thicky, it will not going to spread far. Because the liquid which is here prior to cooling, when the liquid is there, suppose this is liquid, so this liquid is getting more and more silica content, or let's say cooling while remain contacting with the more and more silica content. So as a result of this, what we can say that it is getting more and more thicker because the impurities are more, and as the impurities are more, it is getting more and more thicker. It would not going to spread far because it is like a sticky liquid. Sticky liquid would not go far from the area where we have a. Similarly, these kind of acidic rocks will have a porous grain, means the crystals or the grains which are there in the rocks, they will be bigger. They will not be a fine minute structure, they will be bigger. In granite you will see that we have some sort of bigger kind of grains, porous grains are there. Then these acidic rocks are generally lighter in color, and they are being known as what? Felsic. And they are found usually in the earth crust. Granite is an example of this, and in the last slide I have shown you the image of granite, in which you can find out that we have a porous grain, we have a light color, then we have a like a common appearance in the crustal, continental crustal parts as well. Contrastingly, we have a basic rock, and this basic rock is basically, when it will get cool, it will have a low silica content. When it will have a low silica content which is almost 40 to is there, so that kind of rock would be known as basic. This rock, as the silica content is less, so it will going to cool slowly because it's a purest form of molten rock, and this will be a fluid. It will going to spread far. The purest form of material is there, purest form of rock is there, which is actually coming from the, let's say, core mantle and then appearing on the surface. And this particular set of rocks, those who are cooling slowly, as a result of that, they would have a fine grained texture. If you see that texture, so that would be very fine. If you see, for example, the granite, and here in the granite we have what? Porous grains, like the grain which are visible here, these visibles, or let's say these grains are basically bigger one, and they are visible. If you see this particular rock, so here we also have grains, but the grains are very fine. These rocks, basic rocks, are basically dark colored, and these dark colored rocks are being known as what? Mafic. These rocks are basically common in oceanic crust, widely found in oceanic crust, and the example is basalt. And this kind of division is based on the silica content. Moving ahead,